A bus is traveling at a constant speed along a straight portion of road. The equation d equals 30t gives the distance d in feet from a road marker, that the bus will be t seconds after passing the marker. How many feet from the marker will the bus be 2 seconds after passing the marker? So we have this equation, d equals 30t, that gives us the distance as a function of the time. And we need to find out how many feet the bus will travel after 2 seconds when it passes the marker. So we could just use this equation and plug in a value of 2 for the time to find the distance that the bus travels from the marker. So we'll just have d equals 30 times 2, which is just equal to 60. So after 2 seconds, the bus travels 60 feet from the marker, which is answer choice C. A line in the xy plane has a slope of 1/9 and passes through the point 0, 14. Which equation represents this line? Okay, so the equation of a line is of the form y equals mx plus b, where y is the coordinate on the y-axis, x is the coordinate on the x-axis, m is the slope, and b is the y-intercept. So the problem statement tells us that this graph of the line has a slope of 1/9. So that means our m value should be 1/9. And if we look at our answer choices, answer choice A and B are incorrect because they're saying that the slope is negative 1/9 when it should be 1/9. So we have to choose between C or D. Okay, the problem statement also tells us that it passes through the point 0, 14. Now, 0, 14 has an x-coordinate of 0, which means that this point lies on the y-axis. If we draw this here, we have x and y axes. Those are arrows. So the point 0, 14 is somewhere on the y-axis at a y value of 14, since x is just 0. So that means the y-intercept, where the function crosses the y-axis, is at the point 0, 14. So it would look something like this, the line. So that means our y-intercept should be a value of positive 14. So the only answer choice that has a positive 14 as the y-intercept and a slope of 1/9 is answer choice D. So answer choice D is correct. Answer choice C is wrong because it says that the y-intercept is negative 14, which is incorrect since it passes through the point 0, 14, not 0, negative 14. So D is the correct answer. If x over 8 equals 5, what is the value of 8 over x? So we have this equation, x over 8 equals 5, and we want to manipulate one side so that it looks like 8 over x, and so then we'll know what it equals on the other side. So let's manipulate this to look like 8 over x. So we can multiply both sides by 8. This will give us x equals 8 times 5. By multiplying both sides by 8, 8 over 8 cancels out, and 8 times 5 is 8, just 8 times 5. And then we need to divide both sides by x. So when we divide both sides by x, we'll get a 1 on this side, and we'll get 8 times 5 over x on this side. So this is looking very similar to this, but there's this 5 here. So to get rid of this, we'll just divide both sides by 5. This will give us 1/5 equals 8 over x. Because when we divide by 5, 8 times 5 divided by 5 is just equal to 8. And then 1 divided by 5 is just 5. So then that means that 8 over x is just equal to 1/5 right here. So our answer is 1/5. Triangles ABC and DEF are congruent, where A corresponds to D, B and E are right angles. The measure of angle A is 18 degrees. What is the measure of angle F? So let's draw out these two triangles. We have triangle A, B, C, and triangle D, E, and F. And the problem statement tells us that A corresponds to D, okay, and B and E are right angles. Okay, so B is going to be 90 degrees, and E is also going to be 90 degrees. What is the measure of angle F? Okay. Oh, and it also tells us that angle A is 18 degrees. And since we know that these two triangles are congruent, that means all the sides and all the angles are the same. So if angle A is 18 degrees and angle A corresponds to angle D, then D is also 18 degrees. And to find the angle of F, we just need to remember that all the angles in a triangle add up to 180 degrees. So if we do 180 minus 18 minus 90, we'll get the value of angle F. Because this angle needs to be such that when the angle of F here is added with 18 and 90, it equals 180. So if we do 180 minus the angle of D and E, we should get the angle of F. So when we do 180 minus 18 minus 90, we get an answer of 72 degrees. So angle F is 72 degrees. Which expression is equivalent to this expression here, where M, Q, and Z are positive? So we have this giant expression, M to the fourth, Q to the fourth, Z to the negative 1, times M times Q to the fifth, times Z to the third. Okay, so this is just a rules of exponents problem. And one of the rules of exponents is that when you're multiplying, say, x, that's raised to the power a, with another x, but this one is raised to the power b, as long as the base is the same, which is the thing being raised to the power, so in this case the base is x for both of these, when you multiply these two together, you keep the base the same and add the exponents. So here, x to the a times x to the b is equal to x to the a plus b. So if we had numbers, this would look like, say you had 2 raised to the third times 2 raised to the 2. So when you multiply these together, you keep the base the same and add the exponents. So 3 plus 2, which is just 2 raised to the fifth. So that's how you multiply exponents together, or bases raised to a power, when the bases are the same. So we'll do the same thing here, and we'll just look at which ones have the same bases and add their exponents. So you'll notice that this m here, there was no number up here, like an exponent, like the others, which means that its exponent is actually just 1. And anything raised to the first power is just itself. So m raised to the 1 is just equal to m. Alright. So let's get rid of all this here so we can actually solve the problem. So we have an m to the fourth, and then we have an m raised to the first here. So since they have the same base, we can just multiply them. So then this will just become m to the fifth. Okay, and then we have a q to the fourth and a q to the fifth. They have the same base, so we'll keep the base and add the exponents. 4 plus 5 is 9. Then we have a z over here and a z cubed here. So we'll keep this base the same and add the exponents. So negative 1 plus 3 is equal to 2. The same as 3 minus 1. Okay, so our final answer is m to the fifth, q raised to the ninth, and z squared. We were able to just multiply these together since multiplication is commutative, and these bases are the same, so we can add the exponents. And the only answer choice that has this expression we just derived is answer choice B. So answer choice B is the correct answer. The box plots summarize the masses in kilograms of two groups of gazelles. Based on the box plots, which of the following statements must be true? Okay, so we have two box plots here. So let's first review how box plots work. So here's a little diagram of how box plots work. So here is the box of a box plot. The left edge of the box, this line here, is the first quartile in the data set. And then the other line that is the boundary for the right side of the box is the third quartile. And then the line through the middle of the box is the median of the data set. And then the whiskers out here, which are these long lines, the boundary over here on the left side is the minimum. And then there are some outliers out here, which are outside of the quartile 1 minus 1.5 times IQR range. And then over here we have the maximum of the data set, which is the right-hand edge of the whiskers. And then up here we have the IQR, which is the interquartile range, which is the box, basically. It's the length of the box from quartile 1 to quartile 3. Okay, so now using this information, we can find out which statement is true about these two box plots here. So here we have two box plots. And as you can see, we have no outliers in these box plots. Okay, so answer choice A says the mean mass of group 1 is greater than the mean mass of group 2. Okay, so this does not have to be true because the box plot only gives us information about the minimums, maximums, quartiles, and the median, and the IQR. It doesn't tell us the mean. The mean, we would need every single data point to calculate that. We can only find out what the median is from this line through the box in the box plot. So answer choice A does not have to be true because we have no way of finding the mean of the two data sets for group 1 and group 2. Answer choice B says the mean mass of group 1 is less than the mean mass of group 2. Again, answer choice B is using means, and we have no way to find the mean or to tell which one is greater than the other. So answer choice B is incorrect. We can only have information about the median and these other things in the box plot, but the mean is not a statistic that's on the box plot. The median mass of group 1 is greater than the median mass of group 2. Okay, so the median of group 1 is this line right here, which looks to be at mass of 25 kilograms. And then the median mass of group 2 is right here, which looks to be at 24 kilograms. So the box plots are saying that group 1's mass is greater than group 2. The median is greater than group 2. But answer choice C is saying exactly that. Group 1's median is greater than Group 2's median. So answer choice C must be correct. And if you look at answer choice D, it says the median of Group 1 is less than the median of Group 2. But in actuality, the median of Group 1 is larger, because this line here is further to the right than Group 2's. It's saying that the median mass is 25, but Group 2's median mass is only 24. So D is wrong, and C is the correct answer. The median of Group 1 is greater. The graphs of the given equations in the xy plane intersect at a point xy. What is a possible value of x? Okay, so we have these two functions, y equals 76 and y equals x squared minus 5. So y equals 76, if we draw that on the xy plane here, we'll make some axes, x, y. So y equals 76, so it's just setting y equal to some constant, is just a horizontal line in the xy plane. So it'll look something like this, just a horizontal line. And then the graph y equals x squared minus 5 is just a parabola that is concave up, since the coefficient of x squared is positive. So it'll look something like this. Its origin, the vertex of this quadratic, is not at the origin since it's shifted down by 5 units. So it'll be somewhere down here. Okay, so we need to find the coordinates of the intersection, or really just the x values of the intersection. And we can do that by setting these two equations equal to each other. So we have y equals 76 and y equals x squared minus 5. So y is equal to both of these quantities, so we can just set them equal to each other. So when y equals y, 76 equals x squared minus 5. So I just substituted the value of 76 for y and x squared minus 5 for y. So then we can just solve for the value of x by isolating it. So let's move this negative 5 to the other side by adding 5 to both sides, which will give us 81 equals x squared. And then to find the value of x, we can take the square root of both sides, which will cancel out this squared value here. So we'll just be left with x on the right side, and then on the left side, we'll be left with 9. And since we're taking the square root of something squared, this will be plus minus x. So that means that x is either equal to 9 or negative 9. So x is equal to 9 or x is equal to negative 9. And indeed, if we plug 9 or negative 9 into this equation, when we square it, we get 81 either way. So 81 minus 5 is just equal to 76. So whether it's 9 or negative 9, the two equations here, y equals 76 and y equals x squared minus 5, they still both intersect at a value of x equals 9 or negative 9. So the graph intersects at those two values of x, and the only answer choice here that is either 9 or negative 9 is answer choice B. So answer choice B is correct. To estimate the proportion of a population that has a certain characteristic, a random sample was selected from the population. Based on the sample, it is estimated that the proportion of the population that has the characteristic is 0.49, with an associated margin of error of 0.04. Based on this estimate and margin of error, which of the following is the most appropriate conclusion about the proportion of the population that has the characteristic? Okay, So the proportion of the population with the characteristic is 0.49, but there's a margin of error of 0.04. This means that the interval for plausible values of the proportion of population that has a characteristic will be 0.04 less than the 0.49 and 0.04 greater than 0.49. So the lower bound of the interval will be 0.45 because that's 0.04 less than 0.49, and then 0.04 greater than 0.49 is 0.53. So in this range is the plausible values of the proportion of the population that has the characteristic, which is answer choice A. The rest of the answer choices are outside of the plausible range, like answer choice B and answer choice D. Answer choice C says the proportion is exactly 0.49, but this doesn't take into the margin of error. It is plausible that the actual proportion is within this range of values, so C is also incorrect. So A is the answer. At how many points do the graphs of the given equations intersect in the xy plane? Okay, so we're given these two equations of these two lines, and we can graph them to see how many points they would intersect at. Okay, so I've graphed these two lines in Desmos, which you can do on the testing application. So this is y equals 2x plus 10 and y equals 2x minus 1. So the red line is 2x plus 10 and the blue one is 2x minus 1. And as you can see from this graph, these graphs have the same slope. The slope of both of these graphs is 2. And since the slope is the same, and they have different y-intercept, meaning that these lines don't intersect. So since these lines do not intersect, it means that the graphs intersect at only 0 points. So they will continue on like this without intersecting since they have the same slope, and they're not overlapping graphs since they have different y-intercepts. So there are 0 points where the graphs intersect in the xy plane. So the answer is A. In the xy plane, the graph of the linear function f contains the points 0, 2 and 8, 34. Which equation defines f, where y equals f of x? Okay, so the problem tells us that there's a linear function that passes through these points, and we need to find the equation of that function. So a linear function has the form y equals mx plus b, where m is the slope, the rise over the run, and b is the y-intercept, the y-coordinate of the point of intersection between the line and the y-axis. So to find the slope, we need to find the rise over the run, which is the change in y over change in x. So these points, they give us x, y coordinates for both of these, and we can find the slope by dividing the change in y over the change in x. So the change in y divided by the change in x is going to be equal to, so y goes from 2 to 34. So 34 minus 2 will give us the change in y. And x goes from 0 to 8. So the change in x will be 8 minus 0. So then this simplifies to 32 over 8, which is equal to 4. So the slope is equal to 4. And then the y-intercept, we can find that by plugging in one of the points back into our equation, using the value of 4 for the slope. So we have y equals 4x plus b, where x is the x-coordinate and the y is the y-coordinate, and then b is the y-intercept. So let's use the point 0, 2. So we'll plug in 0 for the value of x. So we'll have 4 times 0. Then we'll plug in 2 for the value of y. So y will be 2. And then we'll solve for the value of b. So 4 times 0 is just 0. So we'll have 2 equals 0 plus b. So b is equal to 2. So now we have everything we need to make a linear function. So we'll have y equals m, which is 4, times x plus b, which is 2. So this is the equation for this line that passes through these 2 points, which is answer choice C. If x over y equals 4, and 24 times x over n times y is equal to 4, what is the value of n? Okay, so we're given these two equations, x over y equals 4, and 24x over ny equals 4 as well. And we need to solve for the value of n. Okay, so using the second equation, we can rewrite this as 24 over n multiplied with x over y. So I just took this x over y out and put them into two separate multiplying terms. And this will still be equal to 4. Okay, so now this x over y, the first equation tells us that x over y is equal to 4. So let's substitute that in. So now we'll be left with 24 times n times 4 is equal to 4. X over y is just 4. Okay, so now we want to solve for the value of n, so let's isolate for n. Let's divide both sides by 4. So that'll cancel out this 4. So we'll be left with 24 over n, which is equal to 1. Because 4 divided by 4 is just 1, and 4 divided by 4 on this side is just 1. Okay, and then if we multiply both sides by n to get n alone, we'll get that 24 equals n. So we multiply both sides by n, so 24 divided by n times n is just equal to 24, and 1 times n is just equal to n. So now we get that the value of n is equal to 24, which is the answer. The function w models the volume of liquid in milliliters in a container t seconds after it begins draining from a hole at the bottom. According to the model, what is the predicted volume in milliliters draining from the container each second? Okay, so we have this equation that gives us the volume of the liquid as a function of the time passed. So the volume is W of t, and t is the time passed. So we can see from this equation that for every second that passes, or when t increases by 1, each time t increases by 1, the volume goes down by 4, because 4 is the slope of this line, or negative 4 is the slope, which means the volume decreases by 4 every time t increases by 1. For example, W of 1 is equal to 300 minus 4 times 1. So this would be the volume of the liquid 1 second after 1 second of time has passed. So 300 minus 4 is just 296. So 4 milliliters of liquid were drained. But then W of 2 is equal to 300 minus 4 times 2, since 2 seconds have passed. So this is just equal to 300 minus 8, which is just 292. So after another second has passed, the volume of liquid went down by 4 again. So for every second that passes, 4 milliliters are drained from the container. Each year, the value of an investment increases by 0.49% of its value the previous year. Which of the following functions best models how the value of the investment changes over time. Okay, so the value of this investment changes by 0.49% every year. So the function that would best model this would have to be an increasing function, because the value of the investment is increasing. So we can rule out the decreasing answer choices, since the value is increasing, not decreasing. Okay, so now we're just down to C and D. So C says it's an increasing exponential, and D says it's an increasing linear. So just by looking at the problem statement, we can see that it's exponential because it says that the value of the investment is increasing by a fixed percentage, 0.49%. It's not increasing by a fixed value or a fixed number, like say $20 every year. That would make it linear since it's a constant change in the investment. But this is a constant percentage change. So say you had $100, and let's just round this to 0.5% to make the numbers easier. Say you had $100 in year 1. Then after in year 2, you would have $100.5. But then in year 3, you would have to take 0.5% of 100.5, not 100. So since 100.5 is greater than 100, 0.5% of year 2's value will be larger than year 1's value. So the actual change will be different, and it'll be increasing every time. So this makes it an increasing exponential function, not linear, because linear would just be it increases by 0.5 every year or some other constant value. But this is a percentage, so the actual change every year is not constant. So C is the correct answer. The solution to the given system of equations is xy. What is the value of y? Okay, so we're given these two equations, and we need to find the value of y that satisfies these two equations. We can do that by just graphing these two lines in Desmos, which you can do in the testing application. Okay, so I graphed the two lines, 24x plus y equals 48, and 6x plus y equals 72 in Desmos. So the red line is the first equation, and the blue line is the second equation. And then we can just click on where they intersect. You can once you're in Desmos in the testing application, you can zoom in to make sure that they actually intersect here. And we can look at the point of intersection. So when you click on the point of intersection, it'll give you the coordinates. So we have negative 1.333 repeating. So that's the x value. And then the y value is the second coordinate, the 80. So the question asks us for the y value. So that's going to be the second coordinate. And in this case, 80 is the second coordinate. So the y value that is the solution for the system of equations is 80. The given equation relates the variables x and y. For what value of x does the value of y reach its minimum? Okay, so we're given this quadratic right here, and we can tell this is a quadratic since the highest degree or the highest exponent is 2. And we know that this quadratic opens upward because the coefficient of the highest degree, the x squared term here, is positive. Okay, so when quadratics come in the form y equals ax squared plus bx plus c, where a, b, and c are constants, then we can use the formula x equals negative b over 2a to find the x coordinate of the vertex of a quadratic. The vertex of a quadratic is this point here for a concave up quadratic, like this quadratic in this case. So, And then for concave down quadratics, the vertex is this point here. So for a concave up, this vertex is the minimum. So at the vertex, we would find the smallest value of y over the whole function. So what we need to do is find the x coordinate of the vertex to find the value of y where it reaches its minimum. So we can just plug that into the formula, negative b over 2a. So for this quadratic, b is equal to negative 14. So we'll have negative and then negative 14 divided by 2 times a. A is the coefficient of the x squared term. So in this case, it's just 1. So 2 times 1. So then that'll be equal to, these negatives cancel out, so we'll just have 14 over 2 times 1, which is 2, which is equal to 7. So the x-coordinate of the vertex here is 7. So that 7 will be the answer. The function h is defined by h of x equals 4x plus 28. The graph of y equals h of x in the xy plane has an x-intercept at a comma 0 and a y-intercept at 0 comma b, where a and b are constants. What is the value of a plus b? So we have this equation here, the equation of a line, and we need to find the x and y intercepts so that we can find the value of a and b, and then we just need to add them together to get our answer. So for the x-intercept, occurs when the value of y is 0. So then x will be equal to a in this case. So we just need to find the value of x when y, or h of x, is 0. So we'll just set h of x equal to 0 and solve for the value of x. So we'll be left with this equation here. Then we can isolate for 4x by moving the 28 to the other side. So we'll subtract 28 from both sides. So we'll be left with 4x equals negative 28. Then if we divide both sides by 4, we'll get that x is equal to negative 7. So at a y value of 0, x is equal to negative 7, which means that a, which is the x value at the x-intercept, is equal to negative 7. Okay, so that was the x-intercept. Now let's find the y-intercept. The y-intercept occurs when the value of x is 0. So here x is 0, and then the y-intercept, or the value of b, will be the value of h of x, or y, in the equation when x is equal to 0. So let's just set x equal to 0. So we'll solve for the value of y, which is just h of x. But the value of x will be 0. So x is 0, so 4 times 0, and then plus 28. And then y equals 4 times 0, which is just 0, and then we'll just be left with the 28. So y is equal to 28 when x is equal to 0. And since the y-intercept occurs where x is equal to 0, then that means b is equal to 28. So now we have the value of a and b. So we can just add those together. So negative 7 plus 28 is the same as 28 minus 7, which is just 21. So the answer choice is A, 21. Square A has side lengths that are 166 times the side lengths of square B. The area of square A is k times the square area of square B. What is the value of k? Okay, so we have, let's say, this square is square B. and it has side lengths of, say, x. And then we have square A, whose side lengths are 166 times the side lengths of square B. So the length of the side of this square is 166 times this length of square B's sides. And the area of square A is equal to k times this area of square B. So we'll just say the area of square B is y. So we'll say it's ky. Okay. What is the value of k? So we need to find out this constant right here that relates the area of square A with the area of square B. So we know that the area of square B is just going to be x squared. So that's going to be y. And we know that the area of square A is just going to be 166x squared. Now if we simplify this, we'll get that 166 squared times x squared is the area of square A. So area of A, this square. And that this area of B is just x squared. So if we find the value of this constant here, 166 squared, this x squared is in both, and so this is just the value of k. This will be the coefficient of x squared, which is the area of B. So k will just be this coefficient. So we just need to square 166. So we can do that in our calculator. So 166 times 166, which is just equal to 27,556. So this is the area of A. And we can see that this giant coefficient here is the value of k, since it's in front of or being multiplied with the area of B. And the problem statement said that the area of A, which is the whole term, this whole term, is k times the area of B. And the area of B is just this x squared. So the coefficient of the area of B is equal to k. So the answer is just 27,556. Scatter plot shows the relationship between two variables, x and y. A line of best fit for the data is also shown. At x equals 25.5, which of the following is closest to the y value predicted by the line of best fit? So we need to find the y value on the line of best fit at a value of x equals 25.5. So the straight line here is the line of best fit for these data points. And at a value of x equals 25.5, which is about right here on the x-axis, if we go up from 25.5 here on the x-axis up to the line, we see that the line predicts a y value that's a little bit above 8. So the answer choice that gives us a y value a little bit above a y value of 8 is answer choice C, 8.2. So 8.2 is the right answer. The measure of angle R is 2 pi by 3 radians. The measure of angle T is 5 pi by 12 radians, greater than the measure of angle R. What is the measure of angle T in degrees? So we have an angle R that is 2 pi by 3 radians, and angle T is 5 pi by 12 radians, greater than R. So angle T is going to be 2 pi by 3, which is the measure of angle R, plus 5 pi by 12. since it's 5 pi by 12 radians larger than r. So to add these fractions together, we just need to turn the denominator of the first fraction here into 12. We can do that by multiplying this fraction by 4 over 4, which will give us an 8 pi in the numerator and 12 in the denominator. And we'll add that with 5 pi by 12, which will give us 8 plus 5 is 13. So 13 pi over 12. Okay, so that's the measure of angle t. And then we need to find the measure of angle t in degrees. Well, we know that 1 pi radian is equal to 180 degrees. So if we divide 13 pi by 12 radians by 180 degrees, or multiply it by 180 degrees per 1 pi radian, we'll cancel out the pi radians, since this had a unit of radians, and we'll get the measure of this angle from radians into degrees. So we have 13 times 180 in the numerator, and we'll divide that by 12. So we'll get 195 degrees. So the measure of angle t in degrees is 195. So C is the correct answer. A scientist initially measures 12,000 bacteria in a growth medium. 4 hours later, the scientist measures 24,000 bacteria. Assuming exponential growth, the formula P equals C times 2 raised to the RT gives the number of bacteria in the growth medium, where R and C are constants, and P is the number of bacteria T hours after the initial measurement. What is the value of R? Okay, so we have this equation, this exponential growth equation that models this problem. And we are given that the initial amount of bacteria in the medium is 12,000. So that means at times t equals 0, which is the initial condition at t equals 0, the initial population of the bacteria is 12,000. So if we plug 12,000 in for P, so 12,000, and then T as 0, we would be able to solve for the value of C. So we have C here times 2, and then this would be raised to the 0, because anything times 0 is just 0. Okay, so then 2 raised to the 0 is just 1, so we'll just be left with a C on this side, and the 12,000 will still be on this side. So that means C is equal to 12,000. Okay, so now we have everything we need in the equation except for the value of R, which is what we're going to need to solve for now. Okay, so our equation looks like this right now. P equals 12,000 times 2 raised to the RT, where R is some constant and T is the number of hours. So our equation, our problem statement here says that 4 hours later, the population becomes 24,000. So we can just plug that in for P and T. Then we can solve for the value of R. So the population after 4 hours is 24,000. So P is just 24,000. We still have the 12,000 here times 2 raised to the R. But then this time, T is equal to 4 because this is 4 hours later. Okay, so now let's divide both sides by 12,000. So when we divide both sides by 12,000, we get a 2 on this side. And we're left with 2 raised to the 4r. Okay, so then here this 2 is just raised to an exponent of 1. And since the bases are the same, we just need to set the exponents equal to each other in order to satisfy this equation. So what we need to find the value of r, we need to solve this equation here, 1 equals 4r. So we can just divide both sides by 4, and we'll get that r is equal to 1/4. So the value of r is just 1/4, which is answer choice B. What is the smallest solution to the given equation? So we have this equation here, and the first step we can do is to get rid of the square roots, and we can do that by squaring both sides. So when we square both sides, like this, it'll get rid of the square roots. So we'll just be left with what's inside. So we'll have x minus 2 squared on the left, and 3x plus 34 on the right. Okay, so now let's expand out this squared term. So we'll be left with x squared minus 4x plus 4, and then we'll have 3x plus 34 on the right. So let's move this 3x to the other side. So we'll keep the x squared, we'll have negative 7x, and then let's move this 34 to the other side. We'll subtract 34 from both sides, so we'll be left with negative 30 equals 0. Okay, now let's factor this out, and if you factor this, you'll get x minus 10 and x plus 3, because negative 10 times 3 is negative 30, and then negative 10 times x plus 3x is just negative 7x, and then x squared, x times x. So this will just equal 0. Okay, so now we have this expression, equation that's factored out, so we can use the zero product property to see what the values of x are. So in this first parentheses right here, if we plug in a value of 10 for x, it'll equal 0, and when we multiply that with any other term, it'll just be 0. So that satisfies the equation. So one of our solutions is that x equals 10. And then in the second parentheses here, if x equals negative 3, then negative 3 plus 3 equals 0. So then anything times 0 is just 0. So that satisfies the equation as well. So x just equals negative 3 as well. But then the question asks us for the smallest solution to the given equation. And negative 3 is smaller than 10, so we'll use negative 3 as our solution. So negative 3 is the answer. Which of the following are solutions to the given equation where a is a constant and a is greater than 30? So we have this equation here, and let's manipulate this so that we can factor by grouping. So let's move this quantity x minus 29 to the other side by subtracting it. So we'll be left with 0 on the left side, and on the right side we'll have x minus a times x minus 29 minus x minus 29. Okay, so the quantity x minus 29 is common to both, so we can just factor that out. So we'll have still 0 on the left. We'll factor out this x minus 29 from both, and we'll multiply it with the x minus a, and then we'll just factor out a minus 1 from the second term. Okay, so now we have this expression here, and we can see that one of the solutions is x equals 29, because when x is equal to 29, 29 minus 29 is 0. So 0 times this quantity here will just be 0 as well, which satisfies the equation. Left and right hand sides will both be equal. And then from here, the solution is x equals a plus 1. Because when x equals a plus 1, a minus a is 0, and then 1 minus 1 is 0. So then this right-hand side, 0 times this quantity, will still be 0. So that satisfies the equation as well. And so that's answer choice, or answer B, and as answer 2 and 3, which are these two solutions. The first choice here, A, is incorrect, because A minus 29 does not equal 0, and A minus 1 just equals -1, so that's not 0 either, so that wouldn't satisfy the equation. So this one is incorrect. So the answer choice is the one with 2 and 3, which is answer choice C.